Okay, our problem here is what mass of magnesium reacts with 8 grams of oxygen. What do we know? Well, we know the magnesium and oxygen are reacting together. So knowing those formulae, we can work out molar mass. We know the mass of oxygen. So therefore, the equation that we're going to be using that connects molar mass and mass, of course, is N, number of moles, is equal to mass over molar mass, or relative molecular mass, either would be okay. So to start with, what do we have? We have our magnesium. Magnesium, of course, exists as Mg, so we can write it like that. Oxygen. Oxygen, of course, exists as O2 molecules, so we're going to have to write it like that. And magnesium and oxygen react together to form magnesium oxide, and the formula of magnesium oxide is MgO. So we've got our formulae balanced. What we need to do is to balance our equation. Because we've got 2 oxygen atoms here in the form of 1 oxygen molecule, we need to balance our MgO with a 2 there. And that, of course, means that we're also going to need to put a 2 over here as well. Right, let's see what information we know. In terms of masses, we're trying to work out the mass of magnesium, and we know that the mass of oxygen is 8 grams. We can forget about magnesium oxide now because we are not going to be considering that in our calculations. Molar masses. Well, we can determine molar masses from a periodic table, or relative atomic masses. Let's have a look at this. Here is our, we can get it to focus. Let's try again. There we go, magnesium. There's 24.3 for magnesium. I'm going to take it as 24 just for convenience sake. And oxygen, there you can see relative atomic mass is 16. So I'll take my magnesium as 24. I can ignore that 2 because molar mass is the mass of 1 mole of magnesium, and that's 24. But in the case of oxygen, O2 here, I'm talking about 1 mole of oxygen molecules. So I've got to multiply my relative atomic mass of 16 by 2 to give me 32. And I can forget about magnesium oxide, but I can put that, if you like, as 40, because I've got 4 plus 16 for that. Ignoring that 2, of course, because the molar mass is the mass of 1 mole of material. The thing that connects all things in our balanced equation, of course, is the number of moles. We've got a 2 to 1 to 2 molar ratio. With that information, we can therefore work a strategy out for this calculation. Firstly, we've got 2 of the 3 variables for oxygen, so we can work out, to start off with, the amount of oxygen. Knowing our balanced equation, it is a 1 to 2 ratio, we can work out the amount of magnesium that we have. And knowing the amount of magnesium and the molar mass of magnesium, again 2 of the 3 variables, we can work out the mass of magnesium. So 3 simple steps we have. Firstly, the amount of oxygen that we have, mass over molar mass. Secondly, the amount of magnesium. And thirdly, the amount of magnesium. Let's see if we can do this. So mass over molar mass, which of course is going to be 8 over 32, which is equal to 0.25. Let's get rid of that. Number of moles of magnesium is going to be twice the number of moles of oxygen, because we've got a 1 to 2 molar ratio. Thirdly, the mass of magnesium, rearranging our equation of course, number of moles times molar mass, take the molar mass up to the top, is going to be equal to 0.5 times 24 equals 12 grams